This math talk builds on our list of exponent rules or power rules that we've discussed so far, and this one is called the power of a product. And we begin with the question, write 3 times 7 in brackets to the exponent 4 as a product of two powers. Now in order to do this, I'm going to go back to our technique of writing in expanded form. So I'm treating this 3 times 7 here as the base, and this 4 as the exponent. And so we understand that exponential notation tells us to write the base, which is 3 times 7, 4 times, all multiplied together. So it's going to look like this in expanded form. 3 times 7 multiplied by 3 times 7 multiplied by 3 times 7, and one more time, 3 times 7. Now we could replace our brackets with multiplication symbols, and we'll do that this way. 3 times 7 times 3 times 7 times 3 times 7 times 3 times 7, and now we have this expression. Now many of you will recognize that order doesn't matter when we multiply numbers. 3 times 4 gives us 12, and 4 times 3 gives us 12. So with that being said, we could reverse the order that we're performing these multiplications. In other words, instead of 3 times 7 times 3 times 7 times 3 times 7 times 3 times 7, we could begin with multiplying all the 3's together. So we could write 3, I'm going to change up my symbol just to be different here, times 3 times 3 times 3 times my 7 times 7 times 7 times 7. Now, to take that just a little bit further, we recognize that 3 times 3 times 3 times 3 in exponential form can be written this way. A base of 3 with an exponent of 4. There are 4 3's multiplied together. Similarly, the 7 times 7 times 7 times 7 can be written this way. 7 to the exponent 4. So now we pause and we take a look at what we have. And we recognize that somehow this exponent and these two numbers appear in our final expression. And it leads to this property, which we refer to as the power of a product. And it goes like this. A times B, so two different bases, raised to some exponent n, is simply A raised to that exponent n times B raised to that same exponent n. Let's try it with a few examples. Just highlighting again, A times B, all raised to the exponent n, is simply A raised to that exponent n multiplied by B raised to that exponent n. So our questions here say, write as a product of powers. My first question is 2 times 5 raised to the exponent 6. I will write 2 to the exponent 6 times 5 to the exponent 6. Now many of you are probably wondering why you would bother doing that. Why not just make the 2 times the 5 a 10 and call it 10 to the exponent 6? I would agree with you. It's really more for algebra down the road when we're using variables, and you're going to see as we get further into the questions what I mean. But let's try it one more time just with pure numbers, with one of those numbers being negative. No different, we're going to leave the negative 3 and the 8 as they are, but give each the exponent. So it will be negative 3 raised to the exponent 10 times 8 raised to the exponent 10. And you know I took care to put the negative 3, in other words, that entire base, in brackets so that it was entirely receiving that exponent 10. I want the whole base to be raised to an exponent of 10. All right, this may make a little more sense, or the reason why we have this rule when we try this example. Now we have a blended situation where we have a numerical coefficient, and a variable, so a 4 and an m. Applying the rule, we write 4 raised to the exponent 2 times m raised to the exponent 2. Now, typically what we would do to simplify this is evaluate the 4 raised to the exponent 2. Well, 4 times 4 is 16, so our final answer is 16m squared. I'm going to highlight the error that a lot of students make. They will give that exponent of 2 to the m, but not to the 4. And they will say that it's equal to 4m squared. And so they ignore the 4. And that is totally incorrect. But it is a very common error that students will make. Okay, moving on. Let's try it with multiple variables. So we're looking at a, b, c, so a times b times c, all raised to the exponent 3. Just like the last example, everything receives that exponent. So it becomes a to the exponent 3 times b to the exponent 3 times c to the exponent 3. And it's done. Now we'll try blending it with one of our earlier rules. And it goes like this. X to the exponent 4 times y to the exponent 3 raised to the exponent 7. Now, the way I see this, I'm going to treat the x to the exponent 4 as one base and the y to the exponent 3 as another base. So here's what I'll do. I'll write x to the exponent 4 raised to the 7. Y to the exponent 3, again, raised to the 7. But now we use our power of a power rule, which has us multiply exponents. So this gives us x to the big exponent 28, because I calculate 4 times 7 and get 28, times y to the exponent 21. So it's x to the 28 times y to the 21. One last one here. Negative 5 is going to receive the exponent 2. The p cubed receives the exponent 2. And the y receives the exponent 2. Negative 5 when squared is negative 5 times negative 5, and that's going to be 25. Using our power of a power rule, p to the exponent 3 raised to the 2 becomes p to the exponent 3 times 2, or p to the exponent 6. And then finally, y raised to the exponent 2 is just y squared. That's all there is to it, and I'm out of time.